We have the quantity 5y minus 2 all raised to the third power. And there's this big misconception about how do we expand this. And so do not do what I'm doing, but this is what a lot of kids do. They take this and they draw an arrow to the first quantity, they draw an arrow to the second, and they think they're going to cube these items, cube this item, and they're done. That's not how you do this. I want you to underline this. We are only going to go through 3 problems, and then I'm going to walk around and help you as you go through the work. So the idea today is not just that you're doing it, but that you're getting it right, even if it takes you multiple times. Please write down the quantity 5y minus 2. Write it down 3 separate times. Each time I want you to put parentheses around it. Raise your hand if you recognize the acronym FOIL. You've heard the terms FOIL before. You need to FOIL something. It's an acronym, okay? And it helps us describe how we're going to distribute items. So the first thing we're going to do is we're going to underline the first 2 parentheses. And I'm going to come off to the side and put FOIL. And I'm going to use that to guide me through. I'm going to forget about this term right here. I'm going to come back to the slide. I'm going to forget about it right now. So the first thing I'm going to do is I'm going to multiply the fronts. So I'm going to lightly circle these if you have never learned how to FOIL. So I'm taking 5 times 5, which is 25, and there's 2 y's, which equals y squared. You're going to provide me honest feedback when I'm done about how well you understood this first example. So I've done the first. Now I'm going to do the outside. So outside, again, I'm going to circle right now. This is an outside, and this is an outside, and I have to include the sign with it. So the first thing I do is I multiply the numbers. Negative 2 times 5 is a negative 10. And notice that we have 1 y between the 2. I've taken care of the outside. Now I'm going to take care of the insides. So the inside would be this negative 2 and this positive 5y. So when I multiply, I'm going to start by multiplying the numbers. Negative 2 times 5 is negative 10. And then we have 1 y between the 2. We have 1 y between the 2. So negative 10y. Taking care of the I. L means last. So what is the last thing in both parentheses? Negative 2 times negative 2. It's very important you include the sign. So negative 2 times negative 2 is a positive 4. We're almost halfway done with expanding this original expression. Please underline these 2 terms. They have the exact same exponents, so I can combine them. A negative 10 and a negative 10 is a negative 20y. I have a plus 4 in back and a positive 25y squared. Now, when I look back to this original expression that I expanded, there's 1 parenthesis I haven't used yet. I need to bring that down. The next term I use is absolutely not a math term. It just often students can relate to the shape that I'm making. Please go ahead and I want you to make 6 lines down below. And every time I make this shape of a rainbow, I'm going to distribute by multiplying, and I'm going to place what I'm able to achieve in one of these places. So I'm going to start by making 3 rainbows. Just watch first. I'm going to take a rainbow here, and here, and here. So basically, I'm taking 5y, and I'm going to distribute it by multiplying to each one of these. So let's do the first one together. So I'm multiplying. What is 25 times 5? You have a calculator if you cannot do that in your head. What's 25 times 5? So I write down 125. Every time we distribute, we multiply. Yesterday, we started learning about exponents earlier this week. So don't tell me there's 2 y's here. If you add their exponents, how many y's are there? 3. I just did the first rainbow. Okay, rainbow is not a math term, but hopefully you can see it's that shape when we distribute. Okay, I'm going to go on to the next one. What is negative 20 times a positive 5? Negative 20 times positive 5 is negative 100. And now I have to count. How many y's do I have? 2. Going on to the third one. What is positive 4 times positive 5? Positive 20. How many y's do I have? 1. I'm 3 rainbows away from being done. I'm going to switch the color here so you're able to see it. So just like I took this term and I distributed to all 3 in the first parentheses, I'm going to take the negative 2, not just a 2 and negative 2. I'm going to do the exact same thing. So I have 3 more rainbows to do. They've been flipped around. They look more like U's, and now we're going to go into these 3 places. Here we go. What is negative 2 times 25? What is negative 2 times 25? Negative 50. And now ask yourself, how many y's do you have total? Don't tell me 1. See how there's a y squared here, kiddos? Y squared. Okay. Now I'm going to do what's negative 20 times negative 2. Negative 20 times negative 2 is a positive 40, and there is 1y. And lastly, positive 4 times negative 2 is a negative 8. So I have 6 different terms here, and I am 15 seconds away from being done. So I start with the very first term, and I look. In the other remaining 5 terms, is there any term that has y cubed? Y cubed? Nope. Y cubed? Y cubed? Nope, nothing. So I bring down 125y cubed, and I cross it out. There's nothing that can be combined with. Okay, now I'm going to look for anything that has a y squared. Okay, hold on, y. Oh, there's another y squared. And I want to combine these. So negative 100 combined with the negative 10, or the negative 50, is negative 150 y squared. Sometimes a common mistake here is we add them as people want to put y to the 4th. Remember, when we're combining, we're just adding or subtracting. We're not distributing here. Okay, then I have a positive 20 and a positive 40 is a positive 60 with the y's. And lastly is a negative 8. This is the correct answer. We're going to write this 3 times. This is our second example. There's only going to be 3 examples in this quick tutorial. And then underline the first 2. Now, I believe, not everybody needs to do this, but I believe kids that are first learning, when you don't see a number in front, put a 1 in front. I think that helps students. Okay, so I'm going to start right now, and I'm going to do F for FOIL. So I'm looking at the very fronts, and I'm going, okay, 1 times 1 is 1. Okay, got that down. And then here's the kicker. I have to add up how many A's. And the mistake students make is they want to say there's 2 A's. When you're distributing, you're multiplying. So I'm multiplying for this front. And when you multiply the same base, you add the exponents as we went over earlier this week. So I end up with a to the 6th, and there's 2 b's, b squared. I have taken care of the F for front. Now I'm going to move on to the O for outside. These are my outsides. First I multiply, so positive 4 times positive 1 is 4. And then I ask myself, how many A's? Okay, I have 3 A's between these 2 and 1 B. So A cubed B. I'm now going to do the inside. So my insides are going to be this inside 4, positive 4, and 1. Positive 4 times 1 is 4. And then I look at the variables. It's A cubed B. A cubed B. And I go on to last. Positive 4 times positive 4 is 16. Now, of these, there are 4 different terms, and of these 4, 2 of them can be combined, these 2, because they have the exact same variables and corresponding exponents. Otherwise, we couldn't combine them. So positive 4 and positive 4 is positive 8. The variables and the exponents as we combine by adding and subtracting remain exactly the same. If you're watching this video, I want you to write down 6 lines. If you're in my class, write down 6 lines. And again, this is not a math term, but I want you to distribute, which means multiplying. And as you distribute, you're going to multiply 6 different combinations, filling in these 6 different blanks, and then combining like terms. Go ahead, come back to this video and press play. So I'm going to start with this one. So 1 times 1 is 1. 1 times 1 is 1, and I have to count up how many A's do I have. I have 9. And how many B's do I have? I have 3. I'm going to start working through this, and you can continue to work with your partner looking up, or you can join me. That is your choice. 1 times 1 is 1. I have 3 and 6, so I have 9 A's, and I have a total of 2 B's. When you distribute, you multiply the front numbers, and then you find the same base, adding their exponents. That's how I get A to the 9th and B to the 3rd. So I've taken care of this first place. Okay, now the next one, I'm going to multiply here. 1 times 8 is 8. I have a total of, looking here, it's easy, like it kind of looks confusing. I have a total of 6 A's and 2 B's. If you see me make a small mistake, just speak up. 16 times 1 is 16. I have a total of 3 A's and 1 B. That's an ugly 3. Okay, now I'm going to do the purple down below. So the 3 purple rainbows. Here we go. Positive 4 times 1 is positive 4. I have a total of 6 A's and 2 B's. Positive 4 times 8 is positive 32. I have 3 A's and 1 B. And 16 times 4, I believe, is 64. And now I'm looking at these, and I'm going, how am I going to combine? So I need to first look at it. Do any of these have A to the 9th and B to the 3rd? A 9th? No, so that's only one. 1, A to the 9th, B to the 3rd. Do any of them have A to the 6th and B squared? Oh, here we go. So they have to have the exact same variables with the same exponents. Okay, so positive 8 and positive 4 combined is a positive 12. We leave the variables and the exponents exactly the same. Okay, A to the 3rd, B to the 1st. A to the 3rd, B to the 1st. 16 and 32. What is 16 and 32? 48? Positive, am I right or wrong here? Positive 48, A to the 3rd, B to the 1st. And there's no other number that's all by itself. Please do me a favor. This was example number 2. And can you please write 14? This is very similar to 14 that you will do for homework. Find the first example that we did today that looked like this. First example that we did today. And on that example, can you please write number 13? This is very similar to number 13. Okay, we're going to go on to one more that was very confusing for students. I'll give you a chance. I want you to know that before we start this, I want you to watch. This is going to be easier than you think. If I gave you, just off to the side here, if I gave you x minus 2 and x plus 3, just watch my work. I'm just going to FOIL this. There's going to end up being 4 different things. So whenever I FOIL, all I'm doing is I'm distributing and multiplying. So I multiply the fronts. You're only watching. I do the outsides to get positive 3x. I do the inside to get a negative 2x, and then I take care of the last one to get a negative 6. I combine, and this is what I end up with. We're doing the same thing, it just looks a lot more complicated. Now, I don't see a number here. Can we put a 1? When we don't see a number, we can put a 1 there. We're going to slow this down. It's our last problem to practice today. So I'm starting with F for the fronts. So I would like you to do something I want you to do something where we can identify the front of both parentheses. Okay, this is the easiest of the 4 different operations. So y times y is simply y squared. These are going to be my 4 different areas. Okay, ready? Now I'm going to take care of the outside. So let's first just identify the outside. This is one outside. And by the way, can we put a 1 in front here? This will help us as well. This is the outside and this is the outside. So I need to multiply this quantity times this quantity. So first I start with the numbers. What is 1 times negative 1? What is 1 times negative 1? Obviously, it is a negative 1. And then I have a y, and I have the quantity 3 subtract the square root of 7. Okay, now I'm going to take care of the inside. So here's the inside. Same concept. 1 times negative 1 is negative 1. I have a y, and then I have this quantity 3 plus the square root of 7. Okay, now we're going to do the last. So, negative 1 times negative 1 is a positive 1. And I have these 2 quantities, 3 plus the square root of 7 and 3 minus the square root of 7. And I'm just going to do this so there's no confusion here. We are going to distribute a few things. So I'm going to write this down. I have y squared. And now when I distribute the negative 1y to these 2 quantities, I end up with a negative 3y. And a negative times a negative is a positive. So positive 1y squared of 7. Do the same thing to the third one. Negative 1 times 3 is negative 3y. And negative 1 times positive 1 is negative 1y squared of 7. So I've taken care of 3 of the 4 different groups. Now this last group is so much easier than you think. I'm going to take a quick break from this and I want to show you something. Okay, I want to take a quick break from this. come over here and look at this. If I give you the exact same thing, the only difference is what you see on the inside. One is positive and one is negative. It doesn't matter if the first one's positive or negative, and vice versa, if the next one's positive or negative, as long as there are different signs in between. When we do foiling, we never have to take care of the O or the I because they always cancel each other out. So if you have the exact same thing like I have up above, the fronts are the same, the backs are the same, and the only difference is the sign in between, we only have to do the fronts and the last. So this would be x squared minus 4. Okay, now let's look up here. If I multiply the fronts, 3 times 3 is 9. If I multiply the backs, a positive times a negative is a negative, and 7 times 7 is the square root of 49, because 7 times 7 is 49. So square root of 7 times square root of 7 is square root of 49. We are almost done. So do you guys see any that are exactly opposite? They're additive inverses. They're exactly the same thing, but one's positive and one's negative. Does anybody see anything up there in this line? Okay, this one right here and this one, right? Okay, simple enough. So I have y squared. Now when I combine these, I'm combining by adding or subtracting. So negative 3 and negative 3 is negative 6. Okay, got it? Done with that, done with that. Already got that done. And now here, well, I know the square root of 49 is 7. So a positive 9 and a negative 7 plus 9 minus 7 is a positive 2. Above this, please write down number 11. This is just like number 11.